The more recent batch of videos I've made have all been mostly about soundproofing on a budget, but this one's different. A lot of people have been wanting a video of the best way to soundproof the wall, and it's not done with acoustic foam. If you're building new or opening up the wall and you actually want to block real noise, this is how you do it. Most interior walls are terrible at blocking sound. They're usually just 2 layers of drywall with some empty spacing in between them. Maybe a bit of lightweight insulation if you're lucky. That kind of setup might give you an STC rating around 30 to 35, and if you're not familiar with STC just means how well a wall blocks sound. At that level, you'll still hear conversations, TVs, traffic, and even low-end rumble coming right through. To actually stop that kind of noise, you need 4 things working together. Mass to block airborne noise, decoupling to stop vibrations from transferring through the structure, absorption to kill resonance inside the wall cavity, basically the insulation, and sealing, because even the tiniest gap can leak a surprising amount of sound. The first step to consider is decoupling. All decoupling means it's separating the drywall from the framing so the vibration doesn't transfer straight through. Without it, low frequency noise like footsteps, subwoofers, heavy machinery will pass right through the studs with very little reduction. Decoupling is most often used on ceilings because that's where impact noise from footsteps is the biggest problem, but it can also be used on walls, especially if you're dealing with low frequency rumbles where you can actually feel the vibrations. In those cases, breaking the direct connections between the surface can make a noticeable difference. There's 3 main ways to decouple a wall. Option 1 is a double stud wall. This is the most effective method. You build 2 separate rows of studs with a 1-inch air gap between them. Each side of drywall attaches to its own sets of studs, and the 2 walls never touches. The reason why this works is there's a complete structural break so the vibrations can't transfer across. And the people that should use it is anyone doing a major renovations where space isn't a concern. It takes up the most floor area, but it gives the best overall results. Option 2, staggered studs. Here you use a single top and bottom plate, but alternate the studs from front to back. 1 layer of drywall fastens to the front row, the other to the back row. Even though the studs share the same plates, the drywall layers don't really connect to the same studs. That separation will reduce the vibration transfers while keeping the wall slimmer than a full double stud build. And option 3, which is the one that you can do DIY, isolation clips or resilient channels. If you're working with an existing wall, you just have to remove the drywall before doing this. This is usually the most practical option. Isolation clips like Whisper clips or Isomax supports metal hat channel, which then holds the drywall. These clips adds flexibility that cuts down vibration transfers. Resilient channels are a cheaper version of the same idea, but they're easy to install wrong. If you fasten them directly into the stud even once, the whole system doesn't work. Clips cost more, but they're far more reliable. The reason why this works so good is the drywall is no longer fastened directly to the studs. Vibrations gets absorbed in the clips system before they even reach the drywall. And this is best used for people that wants to upgrade an existing wall where you don't want to, well, you do have to tear everything apart if you want to add the channels. But the thing is, if you're not dealing with any type of vibration, this whole entire step is not entirely necessary. Now, if you have an open wall, don't worry, we'll get to what you can do if you have a wall that you don't want to tear apart. That's coming up. But still, before adding your insulation, you have to take care of your light switches and your electrical boxes because most of them are just open plastic or metal boxes with wire holes in the back, and every one of those openings is basically a pathway for sound. That's where, well, I think I have one right here. Putty pad comes in. Well, this is just a little chunk of it. Putty pad is a flexible, fire-rated sheet of soundproofing material. Feels a lot like a thick moldable clay. You press it onto the outside of an electrical box, wrapping it completely so it seals the back, sides, and wire penetrations. What it does is it adds both mass and sealing right where you'd otherwise have thin, hollow gaps. Those boxes are weak points in almost every wall, and without treating them, you'll still get voices or TV noise bleeding through, even if the rest of the wall is built perfectly. They're also designed to stay flexible over time and to meet fire code, so you're not creating a hazard inside the wall. And they're surprisingly affordable, usually $7 a box. Well, not a box, each. Once it's sealed, then you can move on to filling the cavity with insulation. Not all insulation is created equal when it comes to blocking noise. The fluffy pink fiberglass you often see in walls or attic is designed primarily for thermal insulation, not sound control. It offers a minimal resistance to low frequency noise like bass and only slightly muffles higher frequencies such as voices. For a little bit more effective soundproofing, you need dense sound absorbing materials like mineral wool. Top choices include Rockwool Safe and Sound or Owens Corning's Thermofiber Ultrabat. No sponsorship. These products are engineered for acoustic performance with dense fibers that excels at trapping mid and high frequency sound waves. Plus, they're fire resistant, adding safety to your build. Insulation and soundproofing isn't about stopping noise entirely. That's the job of mass. Instead, it reduces resonance inside the wall cavity. When installing, fit the bats snugly but don't cram them in. Overcompressing reduces the material's fluffiness, which lowers its ability to trap sound energy. While mineral wool costs more than fiberglass, it's one of the more effective and budget-friendly ways to boost your wall's acoustic performance. Now that the insulation is in, it's time to add mass, and this is where the real sound blocking comes in. The best setup is to sandwich 2-pound mass-loaded vinyl between 2 layers of 5/8 of an inch drywall. Start by hanging your first sheet of 5/8 of an inch drywall onto the studs or channel system. Next, roll out the MLV directly over that drywall. Cut it to size, fasten it with screws and washers, and make sure the seams are tight. Seal all the seams with acoustic seam tape. Then add the second layer of drywall right over top, staggering the seams from the first layer. What this does is combine rigid mass like drywall with a flexible, dense barrier, the mass-loaded vinyl. That layered system is far harder for sound to vibrate through than just drywall alone. Some of the mistakes to avoid while doing this is don't skip sealing the MLV seams. Even a small gap leaks sound. And don't use thin 1/2 inch drywall. Always go with 5/8 of an inch. And don't try to substitute acoustic foam. They're not a noise blocking product. Once the sandwich layer is complete, you've just created the wall's main sound barrier. Next, you'll lock it in by sealing every edge and penetrations. You need everything to be sealed. This step might not feel as important as adding mass or insulation, but makes a huge difference. Here's why. Sound travels through the air, and even the smallest crack or gap will leak noise. And what to use for sealing these gaps is something called acoustic sealant, but I used to not really recommend them anymore because they kind of went up in price, but I did find one that is quite affordable. It's from Red Devil Caulking. I'll have links in the description below of everything I talk about in this video. And also there might be QR codes with the items, just to make it easier. But basically the difference between an acoustic caulking and regular $3 caulking would be that the acoustic sealant, it stays rubbery over time. So even if the door slams out of perhaps anger, then it won't crack. It'll just stay the way it is and sound will stay on the other side. All you do is you run a continuous bead along every edge of the wall, top, bottom, and both sides. Seal all inside corners. Seal around the outlets, light switches, and any pipe or wire penetrations. Smooth it with a caulking tool or just your finger to make sure it bonds tight with no gaps. One mistake to avoid is don't forget the bottom edge where the wall meets the floor. It's one of the most common leaks. Now, once this step is done, the wall is finally airtight, and when you combine sealing with mass, decoupling, and insulation, you've built a serious soundproof barrier. But what if you're not opening the wall and still want to soundproof it? Is there still a good way? Well, of course. In that case, you can build right on top of the existing drywall, and the process is basically the same as the latter steps we already covered. You're just starting with the first layer of drywall already in place. You take a full layer of 2 pounds MLV and fasten it directly to the wall, sealing every seam so it's airtight. Then you install a new layer of 5/8 of an inch drywall over the mass-loaded vinyl. Now, once this step is complete, you just do the same thing as you did with the other step. You take your acoustic caulking and you seal the gaps. You might have to take your baseboard off to seal that bottom gap. It's easy, you just put it back in. Now, of course, this approach won't reach the same level of performance as fully decoupled wall, since you're not isolating the structure or adding insulation inside the wall cavity, but it still does add a serious amount of mass, and mass is biggest factor for blocking especially airborne noise. For walls that are already built and needs a big upgrade, this is the way to do it. All right, before we wrap it up, acoustic panels. This is for echo, not soundproofing. So I want to clear up one of the biggest misconception I see all the time, and that's acoustic panels. Foam panels and fabric wrap panels are often sold as soundproofing, but they don't actually block sound from going through a wall. What they do is absorb reflections inside the room. That means they make the room itself sound quieter and less echoey, which is useful for things like recording, Zoom calls, or watching movies, but they won't stop your neighbor's TV or traffic noise from bleeding through the wall. But that doesn't mean they're useless. Acoustic treatment can make a huge difference in how the room sounds on the inside, and when you combine them with real soundproofing methods like mass, decoupling, insulation, sealing, you get both benefits: quieter room and a better sounding one as well. If your main problem is echo or a hollow sounding room, panels are a good add-on, but if your problem is more sound coming through the wall, don't expect these foams to fix anything. So this pretty well wraps it up for soundproofing the wall, one of the best ways to make a difference. But if you still want to find budget ways to soundproof a wall that you can do for maybe $100, video right there. Thank you very much for watching. Until next time, assuming you subscribed.